Hi, 7th grade. Welcome to your first lesson of Topic 8, Solve Problems Involving Scale Drawings. By the end of the lesson, I want you to be able to say, I can use the key in a scale drawing to find missing measures. Calvin made a scale model of the plane shown. How can you represent the relationship between the model of the plane and the actual plane? So we need to compare it. So 15 inches in the model is equal to 240 feet in real life. What do you notice about the relationship between the model of the plane and the actual plane? Well, if we take 240 and divide it by 15, we get 16. So for every 1 inch, it's going to equal 16 feet. Focus on math practices. Look for the relationships. If the model and the actual plan are to scale, what do you know about the relationship between all the other parts of the model of the plane aside from the total length? The wings are going to be in proportion, the tail, everything is going to be using this same scale. So it is proportional, meaning we can set up our proportions. Example number 1. Find the actual lengths using a scale drawing. The island on the blueprint is 6 inches long. What is the actual length of the island of the kitchen? Scale drawing is an enlarged or reduced drawing of an object that is proportional to the actual object. Use a double number line to represent the scale drawing and the actual length. So every inch is equal to 1.5 feet. So 1 inch is 1.5, 2 inches is 3, 3 inches is 4.5, and so on. Use a proportion to find the actual length of the island. So the scale is 1.5 over 1, and then that's to 1 inch. This is 1 inch. So we want to know what 6 inches will be of actual length. So then you cross multiply. 6 times 1.5 is 9. 9 equals x. The actual length of the island is 9 feet. What is the actual width of the island if the width in the drawing is 2.5? So it's 1.5 feet for 1 inch. We want to know what the width is if it's 2.5 inches. So then we're going to cross multiply. I'm not going to worry about their boxes because we do it a little differently. But then you get 1.5 times 2.5 is 3.75. So the actual width of the island is 3.75. How would the proportion for example 1 change if the scale was changed? You would multiply by a different number. Example number 2. Use scale factors to solve area problems. What is the area in square yards of the deck represented by the scale drawing? So here's our scale. And we need to find area. So we're going to find the actual length and the actual width. So first, we are using, we can use an equation. This is what this box is telling us about. You can use the equation or you can use the proportional reasoning. You can use an equation in the form y equals kx to represent the proportional relationship between the lengths in the scale drawing and the actual lengths. The constant of proportionality is the scale factor. So our equation here is y equals 2x. And then you plug in 16 and 8. So the actual length is 32, the actual width is 16, and then area equals length times width. So 32 times 16, the actual area of the deck is 512 square yards. Reproduce a drawing at a different scale. Students are recreating a landscape drawing shown at the right for a mural. They want the length of the drawing on the mural to be 80 inches. What will the new scale and the height of the drawing on the mural? So right now, they have the scale as 1 inch to 4 feet. but they want the length of the drawing to be 80 inches, and the length is currently 10. First, we're going to find the actual length and the actual height of the landscape. So they're using this length equals k times 10, and we know our scale is 4 from here. So 4 times 10 is 40, and then k is 4 again, times 8 is our height, and that's 32. So the actual dimensions are 40 by 32. Now we want to do a new drawing with 80 inches. So 40 over 80 is our new scale, and we need to reduce it so that it's a unit rate. So we divide by 80 on both the top and the bottom. So the new scale is for every 1 inch, it's a half a foot. So now we got to find the new height of the drawing. So plugging that back in our y equals kx. So 32 equals, we know our scale factor is 0.5, but we don't know what x is. Solving for x, we get 64. So the dimensions of the drawing on the mural are 80 inches by 64 inches. The scale drawing shown represents an existing barn. The shortest side of the barn measures 150 meters. So this part here. If a new barn that is 2/3 its size replaces the existing barn, what will be the scale factor of this drawing to the new barn? Okay, so we need to figure out what the scale factor is first. So 10 inches, 150 meters to 10 inches. We want 1 inch. So this is x. We can cross multiply, or you can just divide by 10. So x equals 15. So that means I can use my equation as y equals kx, y equals 15x, and right now I have the length to be 20. So y equals 15 times 20. So y equals 300. So the long side of the barn is currently 300. But the barn is now 2/3 the size. So we need to figure out what's 2/3 of both 150. So 150 times 2/3 is going to be 100. And 300 times 2/3 is equal to 200. So the new barn's going to be 100 by 200. And now I need to find out what the new scale factor is. So 100 meters is 10 inches. 200 meters is 20 inches. So if I'm using the formula again, y equals kx, I can just use one of them. 100 equals k times 10. Solving for k, I divide by 10. So the new scale factor is 10. Key concept. The scale factor of a scale drawing is the ratio of an actual length y to the corresponding length x in the drawing. The ratio is the constant of proportionality k that relates the actual figure to the scale drawing. You can use a proportion or an equation in the form y equals kx to solve problems involving scale drawings. Okay, 7th grade, let's say it. I can use the key in a scale drawing to find missing measures. Have a great day.